Okay, hello. I think this is a third video lecture since I uh, left for summer conference. Um, yeah, I think um about a week I am um, coming back to the States. So this is the last video lecture of this semester. And next lecture will be um, in class for those who come to the classroom. Online students still remain the same, right? The topic that we are going to work on today is SCAPI. SCAPI is a program written in Python that can be installed in Linux. Um, right now, I'm recording this from Korea. Tomorrow, I'm going to leave for Japan conference. Um, so I didn't bring my Kelly running on Raspberry Pi. So instead, I'm going to do this on my MacBook. Okay, but I believe the functionality of or capabilities of a SCAPI uh, should be the same as the one that I am doing today. All right, but installation of the SCAPI that I'm going to give a demo today is on Mac. Okay, I know many of you are running on Mac, so Mac laptop or desktop. The installation on Mac usually a little um, outlier from the main stream of SCAPI installation, which means those who are still working on Kali or Raspbian on Raspberry Pi uh, will not have any difficulties in problem. All right. So installation steps. We need to first check if there are two things, Python and Ruby. Okay. So you may be able to check on your Linux operating system. This is a command where Python. Then you will be able to see whether you have it or not. Okay. And Ruby also. Okay. Um, those who upgraded the Python to 3.0, then you need to switch back to 2.7 in order to uh, utilize SCAPI fully. All right. Um, if you do not have Ruby, then this is the command that you can do uh, using curl. Okay, and curl takes URL um, as if you are running on web browser. So you can simply do here http slash colon slash row github usercontent.com and homebrew slash install slash master slash install. Okay, so you need to do that. And then what in step 2, what I want you to do is brew install Python. Okay, and then pip install pypcap. Pcap means packet capture. So you need to install module pypcap. So Scapy, which is running on Python, at some points uh, needs to run packet capture. So you need to install this. Next step is to set up your path variable. So this is a path variable. Okay, path equal slash usr slash local. When you do here Python, probably Python or Ruby available on this usr slash local or usr slash local slash bin. Okay, and then path, because they are available, they will be available on either this or that. All right. So finally, dollar path means whatever path defined on your Linux operating systems. If it is a Kali, then Kali's path. If it is a Raspbian, then Raspbian path, or Ubuntu. Okay, so operating system itself has a path expression, which is labeled by $path. So that is appended the to the end of this new path expression. And once you have done that, then what actually um, this should be on this file. Okay, in your home directory, there is a hidden file, bash uh, runtime command. So bash rc. You need to if there is a path expression on this file, then you can add that. Okay. If there is no path expression, then you can type this. After you have a new bash rc file, then you need to do uh, you need to restart of that variable definition. Okay, the command to do that is this: source space tilde, which is my directory, slash dot bash rc. Or if you uh, add this to bash profile, then you may do this. So okay, and then finally you need to install Scapy. But installation of Scapy um, may cause a lot of problems, which is the case that I uh, have been um, trying to resolve. Um, but if your installation uh, does not have any error from this command, pip install Scapy, okay, this is the Linux command, then you simply run Scapy. If errors occur, do the following slides here. All right. So a lot of things that you have to do. You have to do pip install pyx equal 0.12.1 minus uppercase I minus, there's a space, right? Minus no cache to install this pyx, because pyx is one of the dependencies to Scapy. Another thing that you need to do install is crypto, uh, written on py. So pip install py crypto and ecdsa library. You have to install this. Pip install ecdsa. For dnet, if you up to this point, you probably have some errors. After you do this, if you do Scapy, then you still have an error. Then one of the errors, complaints, includes um, missing dependencies. Therefore, you have to install py crypto and also uh, include this library. So you have to do every step. You have to do successfully done with no error. Okay, up to this point, there is no error, but dnet. If we have a dnet error, then you need to do this. brew install space dash with dash python libdnet. All right. After this, and Scapy, because Scapy is one of a powerful um, attack tool, you better use sudo. Okay. So super user privileges may be needed along the way that you are trying to do attack some other infrastructure. Okay, so once we have done, then we can do this. We can try Skype. All right. So we'll do step by step with this. Now I have one terminal for Mac user. If you want to bring up another terminal, then you can do uh, by holding down Command button, press spacebar. Then you have this. There you can do terminal. Wait a minute. And then terminal, right? So terminal. Ah, it means that. Then I think Control N. Control N does not work. Then Command N. By pressing Command N, then you will have another terminal. Right. So this is your home. Right now you are somewhere else. Here, my external drive. Okay. If you do pwd, then there's my external drive is under volumes. Okay. Same thing here. If you want to do, if you reset PS1, okay, prompt statements 1. By the way, what is a current PS1? Then you can do echo PS1, that is a variable, so PS1, then you can see the current PS1. Probably here, same one. I didn't change it, right? PS1, same as that. If I want to do reset, then PS1 equal, and within quote, then you can do within square bracket appears on your um, prompt statements in this case. And then if you want to do JYOON, then that is your name, right? That's what I ask you to do. Your name and dollar sign, greater than sign, whatever this literal, okay? And if you do backslash U, then something about your system, right? And then, for example, if you want to do what I want to do is after this, if I want to do dollar sign PWD and then colon, okay? PWD is a print working directory so that you may be able to see a whole path. That's what happens. So PS1, perfect. This is user within square bracket. That's what I did here. And then dollar $PWD, which means that is the working directory. And after that, I did the dollar sign and colon. So colon JYOON dollar sign greater than sign from here there. So this literally appears here. If you do not like it, then one thing that I want to change this is about no, I don't want to do. I will simply do this. Okay, that's perfect. If you want to do this here again, then you can do this. All right, perfect. So the terminal here is on my external volume. Here is users JUN, which is my current home directory. If I do ls, then I can change it to John's backup, and then there is a mercy, and then 595 pi raspberry pi ls, and then I think I have Scabby. Let me see what I have here in the graphical user interface. Raspberry Pi. I have Raspberry Pi to GCC hacking. Okay, I think Python. Okay, so that I can do cd Python ls. There I have here under Python. I have Scapy Python SCPY. So cd SCPY ls. I have some others. So let's do this each, okay? Oh, this is not open Scapy. So let's do open Scapy. Sudo Scapy see, I do not have any error, right? If you simply do scapy, then not uh, with no execution of those dependencies and proper installation, then you might have a lot of errors. So, so please remove that. Um, on the network, uh, there's a network structure, right? So if you do ls, oh here, by the way, this is scapy. If you want, if you need help, then type help, okay? And if you want to see the modules available on your scapy, then modules, then you might be able to see long list of the modules that you may be able to see, right? For example, DNet that is installed, and if you want to work on the web server, then URL lib, URL lib2, URL parse, various different versions of that, and pyx. Remember that has been installed. Pyx, pycryptor. Pycryptor should be right. May appear in some others. ECDSA. See here, ECDSA. So if you want to do ECDSA, then you can see the description of that. Okay. If you want to see here, that should be run on Python 2.7. So you have to run it, Python 2.7. And types, some of the types, and topics. If you want to see topics, then you can see the topics of those, right? All right. You can simply quit from there. This is Scapy right now. So if you want to exit from Scapy, then the way exiting from Scapy is the same as Python. So quit, open, and close parentheses. The one that I can share with you is I have I can see the hidden. I want to let you know here. Okay, let's take a look at the bash RC. Okay, more dot bash RC. Then see here, I did only path equals $path colon slash USL local colon slash USL local bin. Let's see. Okay, I want to take a look at bash underscore profile. be dot dash underscore, let's see, dash underscore profile. So I have once more that. So what happens here is that in path, in the path expression, and then my Python, where Python, where is not available? Oh, it's not where. Yeah, which. I need to change this. Not where, but which. Okay, if we do where is Python, then I have only one version, right? USL bin Python. So try to see USL bin Python, then you will see the version of that Python is 2.7.10. Okay, so my Python is ready. By looking at your path expression here, and if you simply type Python and see if the version, if any version here is 3.4 or 5, then you need to do, you type which Python, so that you will see which version of a Python is working. Then you can run that expression. So simply slash usr slash bin slash Python. That is the same as that one, 2.7. If there is any difference between this and that, the way simply you type Python, or the way that you type with the expression which is given by which Python command returns. If they are not the same, then you have to fix it. The way that you can fix, you need to link, you need to specify only that path appeared on your path expression. This is path expression, right? So that whatever you have here should have uh, that one, USR slash bin. But if you do this, brew install Python, as you see here, then it brings, yeah, with this, with the Ruby -c, whatever here, and if you type this, then it automatically brings Python 2.7. All right, so let's move. So let's get into Scapy. ls, if you type ls, then that's just an object of the function, which can take something about layered packet. So what about Ethernet? Then you can see the definition, the field name of that if. Similarly, IP, then field name of that. So there's a version, IHL, TOS, length of that IP, flags of that IP. For example, if your IP sends out sync, synchronization serials, or acknowledgement, whatever the flags that you want to do, okay? Similarly, here TCP also works. By the way, it should be cap because Python and Linux is case sensitive. So another the definition of TCP appears here as port, that is sender port. This is destination port. Similarly, here in IP we have sender IP address, destination IP address. So senders and destinations IP address can be found from IP. And also you can define your sender or both destination IP in this IP structure. If you want to specify a specific port for sending or receiving, then here TCP. Similarly, UDP. Okay. And then you can combine this all together. So, for example, A equal ether, then that is Ethernet is already set up. So if you want to see whatever that, then it is this. So source is, this is MAC address, right? This is MAC address. This is destination that is fully open that we can see. And then B equals IP. And if we want to see B show, that is it. So right now source is 127.0.0.1, destination also the same. If you want to change this IP, then you can change it. For example, IP destination equals, say 134, whatever that, I do not know what it is, right? So B show, see here, there's the destination, the way that we set. The beauty of this Skype is that we can specify the packet. We can form a packet as it is described, which means LSIP. I want to describe right now what I did here. IP opening within opening closes parenthesis, DST equal the value. So that is this, DST equals the value. I can also specify the source as if it is not from this but something else. Similarly, flags, I can change it to flags so that flag equals S. Maybe sync. Well, it's not. But anyway, so B, what happens right now? Flags is nothing, right? after this. And then TCP, C equals TCP, don't do anything, but if you want to see this, then that is that. And then we can set up the port, source port, for example. Then TCP destination port, well, it doesn't really matter, right? Whatever that is. So source port equals 80 and destination port equals 443. And then see that show, then this is HTTP, this is HTTPS. That's what we set. If we want to do that all together, then can be E equals, I'm not sure, A slash, what is A? A dot show, that works. B dot show, C dot show, right? So if you want to do A slash B slash C, and then E dot show, then you can see all of those. So Ethernet, IP, remember that 134.3, that's what I did, right? TCP, the port for sending, source, HTTP, destination, HTTPS. So we can form a packet like this. Okay, see here. This is what I did, right? Instead of spelling out ether, whatever the specified within the parentheses, slash IP slash TCP. In this way, slash means in the packet is formed in this way, some tiered, right? Ethernet tier slash underneath IP tier slash TCP tier all together will form a packet. You can specify something that you want to specify within that parenthesis. Okay, this is the structure that you can see, but you can add something in it. So I want you to practice that as we did. And then you can send. So right now this is, what is it? That's E, right? You can send, for example, SR E warning. MAC address to reach destination not found, because that is a fake. I do not want to right now attack any, right? They're all arbitrary. This is also arbitrary. Um, source port open 80 open for sending doesn't make sense, right? But if you want to do something else, that may work. So one packet is created, it goes that way. All right, I want to skip it. So by sending and receiving, we can use some function, SCAPI function. So SL, so we have three functions, SL, SR1, and SRP. SL is sending packets and receiving answers. This function returns a couple of packets and answers and unanswered packets. Similar to SR, if we want to do SR1, then it returns only one answer. I'm not interested in any unanswered packets. Then you can simply do this. This is a simple and lightweight of checking, right? Sending or receiving packets. This is full SR. And we have a SRP, which is two actually, yeah, two packets. So, Ethernet, so three packets, IP and ARP and etc. So three functions are available. Well, later, a few more also. So some examples that you can do here is that, say H equals SR1. I want to see only the answered packet. The packet that I want to form is IP destination equals 10.1.1.2, whatever that is. This is the IP. And then further, another tier is ICMP, okay? And then close the sending packet sending function. Then so it is going, it's sending out. One comment of using Scapy. Remember the last week we did Nmap, so we can network mapping to find out open ports for available IPs, right? So once we have that IP address and the port number, then we can create a packet as we do this week. So combine the topic that we did last week and the topic that we are doing right now together to send a packet, specific packet to a specific um, server through a specific open ports. So I wanted to think the way that we may be able to do uh, intrude. Okay. Sometimes it takes so long. Sometimes there is an error. Sometimes there is all different kinds of the such available. But this is our manual um, method of using Scapy. But if you do this within your Python script, automatically do um, I mean uh, obtaining IP address and port number from Nmap. You have a series of a list of IP address and port numbers. Then you can take each of those lists to form packets to send out automatically. Okay, that is the way that you do for uh, ethical hacking. I want to skip this. I want to stop this by holding down control and C. Okay, if there is any available, oh, right now it is now, right? It's just skipped. If there is any objects available, then you can do SH and show. Then you can see all the whatever you have currently. But right now H is not defined yet. So of course it is not working. So let's try to do the other one here. IP and TCP, specific one. If you see here TCP destination port, it's not just a value but a list of values. You can do that. You can try to uh, intrude multiple different port numbers within the square brackets. All right, let's do that. Okay, send. Okay, warning, don't know how to close the file descriptor. Bugs. Go ahead. Please report this bug. Whatever that. So two packets formed because I opened two ports. So one packet per port. All right, again, I'm going to stop it to see if any objects. Oh, this object is available. Then you can do show. Not just that. In order to see that, then you need to do. We have see here result or unanswered. Okay, of course that is arbitrary, so there is no answer, right? If we want to access the second objects, then do this. There's a second object. And if you want to do show, then you can see that. Among this, if you want to see HTTP, the packet, first packet is packet for 80, second packet is packet to open the port 53. So if you want to see, let's see the port number 53, then you need to do one again, right? First one is labeled 0, second one is 1, so second is 1. So for that domain port, this is domain port, right? FTP data. So IP version 4. This is source, this is a destination, this is what we did, right? Let's try to do this. IP equals 128.126.63.1. I think this takes too long, so stop it. So P, answered and unanswered, right? We can get the result unanswered and unanswered result and unanswered result. The things can be found directly. We can receive it directly, not just by P but together. So on say result comma I think unanswered first, right? As you can see here, the packets can send through SL, but first return value is unanswered. The second return value is answered. So we can see okay, let's stop it. So if we do ends, that is that on ends. The first one is yeah. This should be on ends. This is ends, right? And then if you want to do ends dot summary, then you can see the summary. Ends dot show. So the first element of that, then you can see this destination is this and that. Uh, this slide shows the, the list of references that you may be able to be interested in. If you want to see TCP, ICMP, ARP, address resolution protocol, IP, UDP, then you may access those Wikipedia and get some understanding. So you will be able to see what this means in general. If you want to come to one specific, then let's see the one that we have here, TCP, right? So if you want to see, go TCP. Okay, the whole structure of the TCP, right? This is the same as the way that you can see here, ls TCP, then S port, source port. There is a source port, S port. Short enumerate the field, and D port. There's D port, and sequence number, and acknowledgement number, AZK, and data offsets here. Data offsets 4 bits, and reserved 3 bits. That's reserved 3 bits, and flags. Flags, TCP flags. These are the flags, right? There are 9 bits assigned. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 bits. For example, if we want to set for synchronize, then synchronization, then you can do this S. So back to our slide. I think, yeah, here we may be able to do this, right? Sync. Earlier here in this TCP, we can do flags equals S for synchronize. I think I need to do this. The first return is ends, second return is unends. So ends and unends. So one more time. Meanwhile, let's do this. Okay. So that is the reference. Okay, now we will try to sniff. All right. So stop, ends, that. Oh, now it's the opposite. But anyway, that's what we looked at. Here, sniff. Sniff is a function, another function. Uh, Very similar to Wireshark, but you can filter, and you can set the interface, and then you can do some function. All right. So for example, you can do sniff and iFace equals any. All right. Then you can see the sniffs, but right. And you can stop it. So many others already done, right? So if you want to see that, whatever that, then you can have a label, so variable. So a equals sniff, and Control C, then a has something. So if you want to see a show, right now nothing happens. So let's try to do a little more. So it needs time. Okay, see what happens. So a dot show. Wow, I have so many packets sniffed, right? And if you want to see a specific, for example, HTTPS 18. Okay, it starts from 0. So 18. A dot 18. Then that is 18. Port number. Which one that I want to see? It's 18 here. There's this. Port number 51562. That is HTTPS. So port number 51562, right? If you want to see this, then you can see more clearly here. TCP, IP, all right. But if you want to see IP only, let's see, yeah, first element, then you can see this. If you want to see the second element, then that. Third element, probably nothing, right? So nothing. That's what you can do. Each different layer separately you can see. But if you want to see all together, then you need to use a lambda function. Okay. So here, rather than having it saving it, I want to do prn equals lambda x colon, and then whatever that you have here, I want to show it x dot using the show function. Okay. So if you see this function definition, you can specify interface and some others, filter or whatever, and then the function that you want to execute with the value that you have here in the package that you sniffed. Okay, the packets, I call it X, and I want to show that X, the information of that packet. That's what this means. So instead of calling the function from outside, I want to simply define the function here within the sniffer function. Then you need to do this. So it goes very similar to Wireshark. Okay, but if you want to show TCP only, or TCP. Oops. Similarly, if you want to see raw data only, then you can see also. Row is not defined. RAW small. Layer. Okay, let's try to do more. So, okay, here's the thing that you need to do. Okay, if you want to see specific values of those, then you need to use sprintf function. So let's try to this. Okay, here lambda x right here. So x dot printf. So within that parenthesis, you can specify also within a double quote, and then if you want to see IP, %IP dot source, if you want to see the source only, and then this literally if you want to show arrow sign, and then again destination, then dst destination function. After that, if you want to show the next line, then \n. You see here. So within that quote, I think you need to have another curly braces. So they are repeated. IP. See here, if you have all the way up here, then you have IP. Here IP and TCP UDP. So in the IP, I want to show source IP address to destination IP address. Okay, from my the interface, any interface available on my system. Let's try to see that. Stop it, and if you want to expand more to see the row, then within that quote, still double quote, and I want to have another curly brace. Within that curly brace, raw that percent raw dot load percent and \n. I think I want to see, I do not want to make it a new line after, right after that one, but after row. Okay, so any particular, I have here source and destination, and then the payload. So you can see the payload. Okay, from this source, from that to that destination, I have a payload. This is the payload. So if you want to capture the payload only, then you can do this. Okay, as you can see here. Guess what? When user enter login name and password, those are in the payload of that raw materials. Okay, so if you take a look at this, then you may be able to see a little more of those. Let it go, and okay, stop it. If I want to do filter, filter of Scapi is very similar to Wireshark filter. Let's see if I have any filter information. Yeah, here TCP port 2, something like this. Okay, so we may try to do here. So TCP port 25 or TCP port 80 or TCP port 143 and the same. Oh, I'm sorry. Should be filter. Oops, not this. Altogether should be the value to the filter arguments. Filter equal. So from here, there, they are the filter value. Remember that the previous attempt, we around this time we quickly see the result, right? Right now it takes time. So if we want to see something else, see what happens. Oh, we have something, right? Because I am use web browser. So quickly I can see something. That's what I did, right? Here, one of the port is 80. Okay, stop it. The next topic is, remember that the PRN equals lambda function. So rather than using lambda, I want to define the function like this. So def, this is function name, packet colon, if ALP in packet, and then packet of alp.op is 1, comma 2, then return that. So I want to, instead of specify all these details, I want to do this. That is also possible. Okay, so what I can do here, can define this def monitor packet if alp in pack hardware source there's simply Python function definition, right? Alp mon is a function, takes packets. If the packets has ALP, then return uh, the further description of ALP, hardware source and port source. Okay, source of port number. That's what it is. And then sniff p underscore mon. That's it. That needs address resolution. So I don't know. In what way that ALP is working. So let's try to do right now. No news, nothing about ALP now. What else can I try? Let me try merge blackboard. Oh, came up here something. Okay. Something going on here, right? All right. So I'm going to, meanwhile, I'm going to post our course materials. So file, slides, Scappy. I'm going to remake this, save as PDF, replace. So this PDF, open, to do this. I'm going to display this after today is July 6th. So 12, 1 o'clock a.m. Submit. So hardware, this is MAC address. See here, ALP MAC address and source IP. So IP address. That's what you can see here. So around the time that you see this, then you will be able to see this. Right now this is gray, but like this on yellow icon. You may be able to see. Around the time when you see this, that is of course that. Alright, so I'm going to stop this. The point here is that, remember that rather than doing something, I did this ALP mon, right? So ALP, as you can see here, our hardware source, then you will see this, right? So for example, ALP, then you will have this. Okay, hexacode in 6 digits of those. DOS attack, denial of service. You can do that. For example, I want to do this. What happens here? Defined DHCP underscore discover. I specify the Ethernet with the source random, MAC address, destination is fully, and IP with the source and destination, UDP, and so on and so forth. And after that, we send that DHCP discover, and then loop yes. Keep doing this. So denial of service. Denial of service attacks. All different kinds of source and destination. So a lot of warnings, right? So I do not want you to do this, right, much. I'm going to skip this. How many attacks? Wow, this many times. And SR loop and SRP loop. Remember that SR, there's a sending and receiving function. If we want to do this repeatedly, then SR loop and SRP loop. There's a ping-like function. We can try that. Okay, SR loop IP can be formed. Destination equals www.cnn.com/TCP also. It's like a ping. So if you do here ping cnn.com, it's very similar to that, right? See here, you will see the IP address, ICMP, TTL, time. So I'm gonna skip this. If you want to do ping-like attack. Finally, Python script, mail sniffer.py. You can define this, right? So from scapy all import star and then definition pk call pkt if pkt tcp dot if there is a payload, then mail packet is defined as a string which is from packet TCP dot payload, and also if user not, let's skip this, okay? But I want to print anyway all. So print server destination print okay sniff. I don't want to filter any, but prn equals pkt cl which one is that? TCP not found. Strange. PKT. So string should be written that destination that. Let's try all of this. So if I want to do mail, let's try to do mail, for example. All right, so compose or study view, sample, test, send. Nothing came up particularly. Yeah, when it comes to this, that port or that port or that port, then you may be able to see some, but right now, maybe it's not available, right? So, meanwhile, oh yeah, this is I think this is the end of today's lecture. So if you wait some, then you may be able to see some. If there is some mail and mail payload through, yeah, I have it here filter, right? So let me stop this. Let's see if I don't have this. Yeah, I need to have that TCP filter, because some other filter, when it comes, then remember that our here it try to, given packet, try to see the TCP payload, but if we do not have a filter for TCP packets, then according to this function, there is an error. That is the thing, right? All right, I think this is it for today's lecture. So I'll see you in class next time, okay? By then, have a good time.